Today we're going to go over the Unit 6 Systems Test Review. Number 1 says the graph below shows the lines y equals 5x plus 4 and y equals 4. And it asks what is the solution to the system. Remember, the solution is just merely where the two lines are intersecting. So because it's a graph, we can just go look at the graph and see what the coordinate would be for that point. And so that is at 0, 1, 2, 3, 4. So we are looking for 0, 4. And so B would be the solution. Number 2 says graph the following system of linear equations. And then it says for what value of y will f of x equal g of x. So let's go ahead and graph first. So we remember that f of x is just a fancy way to write a y. And this is in slope-intercept form. So my slope is going to be a positive 2. And because we're going to use it to graph, I'm going to make it over 1. And my y-intercept is going to be at negative 1. So on the y-axis, I begin at negative 1. From that point, I'm going to rise 2 and run 1. Rise 2 and run 1. Rise 2 and run 1. And then I'll draw my line to connect those points. Alright, and then the next one. Again, the g of x is just the fancy way of saying y equals. And again, it's in slope-intercept form, so my slope is going to be 1/2. My y-intercept would be a positive 2, so I'll begin at positive 2. And then I'm going to rise 1 and run 2, rise 1 and run 2. And I can draw my line, and I can see where the two lines are intersecting. So the point of intersection would be this point right here. And the coordinates would be a positive 2, and then we went up 3. So a positive 2, positive 3. But the question was for what value of y will f of x equal g of x. So all we really need is that y value. So I'm going to say y equals 3. And there would be my answer. Okay, number 3 through 6, it is saying solve the following systems using either substitution or elimination. It depends on how they're set up as to what we're going to do. So number 3, the way that this is set up, I can see that I have a variable that's by itself, so I'm going to be doing substitution, which means I'm going to take this information and I'm going to substitute it for y in my other equation. So I'm replacing this y with all of this information. So I will have 7x plus x minus 4 equals 4. Now we can finish this by hand, or we can do insolve on the calculator. I'm just going to go ahead and do it by hand. 7x plus x would be an 8x. And then I will need to add 4 to both sides of the equal sign. That will leave me 8x on the left, and on the right I will have 8. I'm going to go ahead and move that up here since I ran out of space. And then the last step to solving for the x, I will divide both sides of my equation by 8. And so I will end up with x equals 1. Now, I'm solving the system, so that means I have to have a coordinate point. Well, my x is 1, and we need to figure out what the y is. So I'm going to take my x value of 1, and I'm going to replace it in place of my x right here, and solve for the y. So now I have y equals 1 minus 4. And so 1 minus 4 will give me negative 3. So the y value will go right there. And here's my solution. Okay, the next one, again, let's look at what we have. It looks like, again, I'm probably going to do substitution because I have a y value by itself. So I'm going to take this information here and replace my y in the other equation with that. So I'm going to have a negative 4x minus 5 times all of this information right here. So the 8x plus 13 equals 23. Again, I could put all this into insolve, or I could go ahead and solve it by hand. I'm going to do it by hand, but of course insolve would be much faster. So I have to distribute the negative 5, so I'll have a negative 40x, and then a negative 5 times 13 will give me a negative 65, and that will equal 23. Sorry, 23. Combine your like terms, so I have two x values. I've got a negative 4x minus 40x, So I have a negative 44x minus 65 equals 23. I need to add 65 to both sides of my equation. That's gone. It leaves a negative 44x equals 88. And then I will divide by negative 44. And that will leave me a negative 2 for my x. Again, I need to take then that x value of negative 2, and I'm going to replace my x here and solve for the y. So I will have y equals 8 times negative 2 plus 13. So 8 times negative 2 is negative 16. And I add 13 to that, and I will actually end up with a negative 3. So my final solution would be negative 2 for the x and then negative 3 for my y. Okay, we're still solving. This time I think I'm going to do elimination because of the way it's set up. I have my x values and my y values all lined up nicely for me. So if I just add my two equations together, I have 2x plus 3x, which will give me 5x, 4y plus a negative 4y, that is gone. And then negative 4 plus negative 16 will give me a negative 20. And then I just divide by 5 on both sides. And I will end up with a negative 4 for my x value. Remember, we need two values, my x value and then my y value. So now I will take my negative 4 and I will replace an x in either equation, this one or this one, it doesn't matter. I'm just going to take the first one. So I'm going to have 2 times negative 4 plus 4y equals negative 4. Again, at this point, I could put this into InSolve, or I could just go ahead and do it by hand. So let me just do this by hand. I'm going to add 8 to both sides of my equal sign. That leaves me 4y on the left, and on the right I will end up with a positive 4. Divide both sides by 4. And I will have 1 for my y. So my y value is 1. My x value is negative 4. So there would be my answer for number 5. Let's do it again on number 6. On number 6, I see again I could do elimination. My x values and my y values are kind of lined up nicely. The only problem is I won't eliminate anything because I don't have the same coefficients in front of my variables. So I can fix that. In order to eliminate, not only do they need to be the same variable but opposite signs. This one is a positive and this one is a negative. So if I make this a 3, then the y values will cancel, or my y terms rather. So I'm going to distribute everything by 3 for that second equation. So my first equation is going to stay the same. So I'm just going to write it right here. And then my second equation I'm going to distribute. So I have 3 times 5y, which is 15, 3 times 5x, which is 15x. Then I have 3 times negative y, which is negative 3y, equals, and then 3 times 3, which will give me 9. Okay, at this point now I can add. 2x plus 15x will give me 17x. 3y plus negative 3y is gone. And then I have 8 plus 9, which will be 17. And then just simply divide by 17 on both sides. And so my x is going to equal 1. So for my x value, we'll have 1. Now we have to do some substituting to figure out the y. So I'm going to take my x value of 1 and I'm going to replace it in this x. Again, it doesn't matter which equation I use. I will just take the top one though. So I'm going to say 2 times 1 plus 3y equals 8. Again, I could put this into InSolve, or I could just go ahead and do it by hand, which I will. I will subtract 2 from both sides. I have 3y equals 6. Divide by 3 on both sides. and I will end up with y equals 2. So my y value is 2, so my final answer is going to be 1, 2. Okay, number 7 and 8 is asking us to, it says for the problems, draw a graph for the system of equations that is shown. And then in the blank provided, identify each system as having one solution, no solution, or an infinite number of solutions. And then if the system has one solution, we need to name it. Okay, so let's look at number 7. I have, both of my equations are in slope-intercept form. So again, I can identify my slope, which is going to be -1/1. And my y-intercept is 7. So if I go to graph 1, 2, 3, 4, 5, 6, 7 on the y-axis, and then I'll go down 1 and over 1, down 1 and over 1. So this would be my first line. Since I don't have a ruler, this makes it a little easier to draw my line a little straighter. Okay, so there's my line. Not perfectly straight, but there you go. All right, so let's look at the second equation. Again, it is in slope-intercept form. So let's identify my slope is going to be a +2, and we're going to make it over 1 since we're using it to graph, and my y-intercept is 1. So on the y-axis, I start at 1, and then I'm going to go up 2 and over 1, and up 2 and over 1, and up 2 and over 1. So as soon as we cross the first equation, we can stop. So we can identify our point of intersection. It is crossing right here. So as far as one solution, no solution, or an infinite number of solutions, it definitely has one solution. So I'm going to write one solution. And then it did say if it has one solution to identify what it is. So I'm going to name it. Let's see. It goes over 2. And then we went up 1, 2, 3, 4, 5. So a +2. +5 would be my answer for number 7. So let's try number 8. My first equation, again, is in slope-intercept form, so I can identify my slope as 1. I'm going to put it over 1. Sorry, I'm going to put it over 1 since I'm going to use it to graph. All right, and then my y-intercept would be a +2. So I will go to +2, and then I will go rise 1, run 1. So up 1 over 1. Okay, I'll just put a bunch of points on there. Go the other way. Okay, it's probably enough. And here's my line. And for the next one, it looks like it is in standard form. So we can do our find our x and y intercepts. So if I look for my x-intercept, my y value is always 0. So basically this is gone and it leaves me 4x equals -8. And to solve for the x, I just simply divide by 4. So x would equal -2. So my x-intercept, it will be -2, 0. So I'll plot that point, -2, 0 is right here. And then my, let's do it again, but this time I'm finding the y-intercept. So when I find the y-intercept, my 0 is always, my x is always 0. So that means this is gone. It leaves -4y equals -8. Divide by -4 on both sides. And so my y value would be a +2. So that means I have 0, 2 for my y-intercept. So 0, 2 is right here. So if I were to connect those, draw a line and connect those, you guys can see that I end up having the very same line, right? So for the same line, that means I have an infinite number of correct, solutions. So I'm going to say infinitely many. Would be my answer for number 8.